One of the key topics in database design is database normalization. Let's take a deep dive into this topic. What is normalization? Normalization is a method of organizing data into multiple tables to limit data redundancy. Data redundancy is the repetition of data within a database. Data redundancy can increase the size of the database. Data redundancy can lead to insertion, deletion, and update anomalies. An example of an update anomaly is when you have duplicate data in multiple fields in the database. If you update just one of those fields, but not all the fields, the data that should be the same in all locations is not. Let us look at an example. I love to do historical recreation sewing and have many patterns that I would like to organize into a database. Let us look at the requirements for such a database. I would need the following fields: pattern item, item yardage, pattern package ID, pattern package price, pattern manufacturer, and pattern manufacturer website. In the unnormalized pattern database, I have one table, pattern item, with the primary key of pattern item and the other fields of item yardage, pattern package ID, pattern package price, pattern manufacturer, and pattern manufacturer website. In this single table, there are rows that have values for each of these fields. For example, the Satana pattern has yardage of 5.5 yards, is part of the pattern package MA009, which is the Italian ladies' wardrobe. It costs $40, is manufactured by Margot Anderson, whose website is margospatterns.com. Note, there are multiple values in some of the data values. For example, the second pattern item has sleeveless shift, drawers, and kamika. The item yardage field for this row also has multiple values. What is first normal form? In first normal form, each cell must be single valued. Entries in a column are of the same type. Rows are uniquely identified. All data values are atomic. An atomic value is a value that cannot be divided. The following shows our pattern item table in the first normal form. As you can see, the fields that were multi-valued have been given their own row. Each row has fields that are single-valued or atomic and cannot be split apart farther. At this time, for best practices, I have also changed the primary key on this table to an integer ID that auto-increments. However, there is still a lot of duplicate data. Looking at the pattern package price column, the price for the 008 Italian ladies underpinning package is listed repeatedly, as are the pattern manufacturer websites for Margot Anderson and Reconstructing History. What is second normal form? In second normal form, all attributes, non-key columns, depend on the key. Looking at the pattern item table, the pattern package price, pattern manufacturer, and pattern manufacturer website do not depend on pattern item. This leaves us with two tables, pattern item with primary key ID and fields pattern item and item yardage, and the pattern package table with primary key pattern package ID, pattern package, pattern manufacturer price, pattern manufacturer, and pattern manufacturer website fields. The two tables are now shown with their primary key field highlighted in yellow. However, there is still duplicate data. The websites for Margot Anderson and Reconstructing History are still duplicated, though the pattern package price is no longer duplicated. Some information is missing, though. What pattern package does each pattern item belong to? To hold this missing relationship, second normal form introduces the junction table. The junction table has the composite primary key showing the relationship between the pattern item and the pattern package. What is third normal form? In third normal form, all attributes can only be determined by the primary key. In our example, the pattern manufacturer website is not determined by the pattern package, but by the pattern manufacturer. This leaves us with four tables: pattern item with ID, pattern item, and item yardage, pattern package with pattern package ID, pattern package, and pattern package price, the junction table with ID and pattern package ID, and the pattern manufacturer table with pattern manufacturer and pattern manufacturer website. Note: all items are functionally dependent on the primary key, which is highlighted in yellow for each table, and there is no duplicate data. The following entity relationship diagram shows the relationship between all four tables. As you can see by the crow's foot notation, each pattern item has one and only one record for one and only one record in the junction table. The pattern package table has one and only one record for each record at the junction table, but the junction table may have multiple records for each pattern package. Each pattern package has one and only one pattern manufacturer, but each manufacturer may have multiple pattern packages. In shorthand notation, the pattern item table has primary key ID and fields pattern item and item yardage. The functional dependencies are that pattern item and item yardage depend on ID. The table pattern package has primary key pattern package ID and fields pattern package and pattern package price. The functional dependencies are that pattern package and pattern package price rely on pattern package ID. The table pattern manufacturer has fields pattern manufacturer and pattern manufacturer website. The functional dependencies are that pattern manufacturer website relies on pattern manufacturer. Lastly, there is the junction table item package with fields ID and pattern package ID. Note: there are no attributes in the item package table that depend upon the composite primary key of ID pattern package ID. Therefore, in this particular instance, there is no functional dependencies.